Welcome to the Rich Report, a podcast with news and information on high-performance computing. Today, my guest is from Mellanox. We have Gilad Shainer. He is the VP of Marketing at the company. How are you doing this morning, Gilad?
I'm doing great. How are you, Rich?
Great, great. You know, when this airs, we're going to be very close to SC16, something many of us are looking forward to. And I understand you have some very exciting announcements to tell us about today.
Yeah, definitely. And, definitely the title of the podcast about news and information, it's definitely going to hit both.
Yeah.
So yes, we're very excited at Mellanox. We are announcing the new generation of InfiniBand technology, the new generation of data speeds. We're announcing 200 gigabit per second solutions to enable the next generation of high-performance storage, machine learning, database, and big data infrastructures. So it's definitely exciting times. And it's not just the new data speeds that we introduce. We also bring with the new technology more capabilities, more acceleration engines, more in-network computing to enable a faster data analysis and doing things in real time, which is required by many of emerging high-performance machine learning applications and more.
Wow. So Gilad, it seems like not so long ago you were introducing the EDR generation of InfiniBand at 100 gigabit a second. When was that, like 2014?
Yeah, we did announce EDR, 100 gigabit per second InfiniBand, in the later part of 2014. And we shipped a full system, so ship the full infrastructure for systems in 2015. Yes, in the networking area, the technology cadence is around every 2 years. So yes, end of 14 we announced EDR 100 gigabit per second, and it seems like almost yesterday. And now at supercomputing end of 16, we're announcing the new generation of 200 gigabit per second InfiniBand. And by the way, announcing 200, we already started working on the 400. So it's never ending story on the development of new technologies, and that's definitely required when you see the ever-growing demand for more performance and higher speed in the HPC area.
Yeah, it's an ongoing thing. Well, Gilad, why don't we do your slides here? I've brought those up, and we'll do a Q&A at the end. Sound good?
Sounds great. So, we are today going through an interesting technology transition. And, in Mellanox, and not just Mellanox, we did talk about it in multiple occasions. We've talked between us in multiple podcasts and things. We are in a technology transition that gonna change or does change the data center architecture from being a CPU-centric, which means that you need to wait for the data to reach the CPU before you can do anything on the data, to a new architecture, which is more data-centric architecture. And that's being done by a co-design development. And a data-centric architecture enables you to work on the data wherever the data is. So you don't need to wait for the data to go all the way to the CPU. And of course, in a world of growing amount of data and the need to analyze data faster in real time, that's actually a big performance bottleneck. So the move to data-centric comes to solve those performance bottlenecks, enable people, users, to work on the data wherever the data is. And from the network perspective, that means that now the network becomes more and more intelligent. The network becomes a CPU within the infrastructure. The network enables you to run data algorithms on the data itself. So the network delivers in-network computing elements. So that changed the data center architecture from CPU-centric to data-centric and enables us to overcome the performance bottlenecks of today and to enable the next generation of applications, if those are in high performance or machine learning or other areas. So as part of the data-centric approach, you need to bring more intelligent, but also you need to bring faster speeds. So at Mellanox, we're very proud to announce the new generation of InfiniBand and to introduce the 200 gigabit per second HDR technology and solutions. And I think this is the first time that Mellanox announced the complete solution for a new technology. And this is what we're doing for HDR. So we are announcing the switch, the quantum switch, the world's first 200 gigabit per second switch solution for the 200 gigabit per second technology. And we're also announcing ConnectX-6, which is the world's first 200 gigabit per second adapter. Now, ConnectX-6 supports both InfiniBand and Ethernet. So we're bringing 200 gigabit per second into both technologies. Quantum supports InfiniBand only, and the combination of Quantum and ConnectX-6 enables users to build a full end-to-end 200 gigabit per second network infrastructure. So here we present the main highlights for both the Quantum switch and ConnectX-6 adapter. So on the Quantum side, Quantum supports 40 ports of 200 gigabit per second InfiniBand, which is an increase of the radix from 36 ports today of EDR to 40 ports of 200 gigabit per second HDR. But not only that, Quantum also supports up to 80 ports of 100 gigabit per second HDR 100 InfiniBand. HDR 100 ports provide the same capabilities of HDR, but in a 100 gigabit per second speed. So Quantum delivers a radix of 40 ports of 200 or 80 ports of 100. And it will be used in building multiple form factors of switch boxes or switch systems, from 1U all the way to modular switches. And in a modular switch, will support, or the biggest modular switch will support 800 ports of 200 gigabit per second or 1,600 ports of 100 gigabit per second. So, Rich, I think you were part of the old Sun system that was built back then, which had 3,456 ports. And I believe it was 40 gig, if I remember correctly.
Yeah, the old Magnum switch, right?
The old Magnum switch, right. So we're not going all the way to 3,000 in one modular switch, but here in a modular switch going to 600 ports of 100 gigabit per second, that's something that fit multiple new generation of platforms and enable users to change the economics of the data center. Beyond that, the switch runs or supports 16 terabits of switch capacity with a latency of 90 nanoseconds. So it's the lowest latency in the market today, and almost 400 million messages per second per port. In my perspective, the more important element of the Quantum switch is the in-network computing to enable data aggregation and data reduction protocol to be executed on the switch fabric by the switch fabric. So that's what enables users to achieve a 10x performance improvement for MPI or Schmem-Pigas operations or machine learning operations. So that's the important element or the key element for in-network computing for the data center architecture. Quantum also enables to support flexible topologies, to build any topology that people have in mind that is better fit to their applications, if it's Fat-Tree or Torus or Dragonfly or Mesh or any other topology. And of course, as a switch, it also enhances the adaptive routing and the routing capabilities that the switch provides. So this is on the Quantum side. On ConnectX-6, on the adapter, So ConnectX-6 brings the 200 gigabit per second era for both InfiniBand and Ethernet. It increased the message rate from 150 million messages that today we support with ConnectX-5 for EDR for 100 gigabit per second to 200 million messages per second. So that's a 33% increase in the message rate. It supports both PCI Express Gen 3 and PCI Express Gen 4 connectivity. It has an integrated PCI Express switch and the multi-host technology that enables ConnectX-6 to connect multiple servers together. So that enables a cost-effective infrastructure for users that require less than 200 gigabit per second to a specific server. And as I said for Quantum, in my perspective, the important element of ConnectX-6 are those acceleration engines. The engines that provide the in-network computing for collectives, for doing MPI tag matching in hardware, for also doing MPI rendezvous protocols, all the way to the network hardware. It has accelerations for NVMe, for NVMe over fabrics, for security, the network offloads, and many more. And we'll go a little bit in more details on those acceleration engines in the later part of the presentation. So with ConnectX-6, Quantum, and with LinkX, which is the family of cables and transceivers, we complete the generation of 200 gigabit per second and enable people to move to the next level of performance and network capabilities. LinkX, on the cable side, we already announced the 200 gigabit per second cables in the early part of 2016. We did a demonstration around that. And with LinkX, we'll offer both copper and silicon photonics fiber cables in different lengths and different reach to provide the needs for the different HDR 200 gigabit per second infrastructures. Mellanox also provide the software suite HPCX, which is a full MPI SHMEMPIGA CPC software suite that can be used for both commercial and open source application, and it leverages the acceleration engines that we have within the switch and the adapter to increase the performance of the various HPC, machine learning, and other applications. So as we move forward, we see greater need for speed and for intelligence. And I think the needs for applications continue to increase for both, again, the speed and the intelligence. Speeds of 40 or 56 even starts to become inefficient for more applications and definitely for systems in larger sizes. Many applications of today utilize the 100 gigabit per second EDR to deliver the best performance, but we already see the need for 200. We already see the need for 200 today. And so looking at the market, I think we're a little bit late. Even though we're first to market with 200 gigabit per second HDR, people could use 200 gigabit per second today for many of their applications. We already see the need for 400 gigabit per second. So systems are going to become bigger. There are going to be greater demands from the network on both speed and intelligence to deliver the needs for the data-centric architecture. So the need is there. We already have a system that plan to use 200 gigabit per second in 2017 timeframe. And as we announce 200 gigabit per second, we already started working on the 400 gigabit per second. So it's definitely an exciting area to be, and definitely very exciting technology to develop. So let's move into ConnectX-6 details and review a little bit more about what ConnectX-6 provides to compute and storage infrastructures. So for performance elements, as I mentioned before, ConnectX-6 is the world's first 200 gigabit per second InfiniBand and Ethernet adapter. delivers 200 million messages per second, which is more than 2x higher versus the competition. It has 32 lanes of PCI Express Gen 3 and 16 lanes of PCI Express Gen 4 and an integrated PCI Express switch. So you can connect PCI Express devices directly to the adapter itself. It delivers highest scalability. And the engines that enables in-network computing enables to work on the data wherever the data is. We also have an in-network memory elements, which are memory element that exist on every adapter and are accessible to the application. So ConnectX-6 enables distributed memory across the data center, in which application can use for semaphores, can use to put data that is required to be shared by multiple processes, and that's enabled that data sharing to become much more efficient versus the options of today, which is limiting the data to be hosted in the CPU memory, for example, and requires applications to go all the way to the CPU to be able to read shared data. The acceleration engines for NVMe over fabrics, for data encryption and decryption, for adaptive routing, make ConnectX-6 the highest scalable adapter for compute and storage infrastructures. ConnectX-6 enhanced the multi-host technology to be able to support up to 8 different hosts to connect to a single adapter. So for infrastructures that require 200 gigabit per second speeds, ConnectX-6 is the best device for that. For infrastructure that requires less bandwidth, you can still use ConnectX-6, but connect a single adapter of ConnectX-6 to multiple servers, up to 8 servers. So in those infrastructures, the server will get 25 gigabit per second, but you have one adapter that serves 8 servers. So one adapter, one cable, one speed switch port for 8 servers. So that delivers lowest total cost of ownership for different kind of infrastructures. It has integrated IP over InfiniBand gateway for single wire solutions for InfiniBand. And of course, InfiniBand is standard. It's open. There's a huge ecosystem support, and therefore it's the best technology, not just performance-wise, but also for the best price performance or cost performance. Here we see the high-level architecture of ConnectX-6. I mentioned the in-network computing engines, the in-network memory, and the other parts. You see the ability to connect multiple PCI Express devices, which is an example of SSD, but it could be any other PCI Express device, to the ConnectX-6 adapter. Here we see some highlights on the in-network computing acceleration engines that exist in ConnectX-6. So first, we continue to carry the native RDMA, which enables to move 200 gigabit per second data in less than 1% CPU utilization. So that's what made InfiniBand or RDMA the de facto solution for storage, for example, or to move data. Essentially, you don't use the CPU for moving the data around. And also the network transport. InfiniBand has full network transport in the InfiniBand devices, so all communications are managed and operated by the network itself, which again maximize the CPU availability for the applications. For performance-driven elements, ConnectX-6 has the collectives communication support in hardware with the Core Direct technology, so that accelerates MPI or MPIGAS applications or machine learning applications, which also use collective operations, and enables to get to much higher scaling and speed. And it also brings the capabilities of offloading MPI tag matching and also the MPI rendezvous protocol. So more and more MPI elements are actually being moved out from the CPU and be managed and executed by the network, which will make it much more efficient and at much higher speed and greater performance. On the storage side, beyond of RDMA, ConnectX-6 introduced NVMe over Fabric offloads, the T10 diff offloads, and other data protection offloads, which improve the efficiency of an end-to-end or enable an efficient end-to-end data protection. It enables multiple other things. One example, it enables to do a background checkpointing for MPI. So today, people use checkpointing for applications to have a copy of the best or the last good known status of the application. So if something happened and the application crashed, you can go back to the last known and start from there, not start from scratch. Doing that checkpointing takes time and a lot of cycles. And with ConnectX-6, we now enable to do the checkpoint in the background by the network itself without the need to actually request anything from the CPU. So it greatly enables greater performance and scalability. Security becomes very important in many areas. And ConnectX-6 now introduce new block data encryption and decryption engines based on the IEEE XTS standard and also key management. And it's compliant, it's a FIPS compliant to the Federal Information Processing Standards. It enables enhanced data security options. It enables to do protection between different users. So today, some people use encryption, decryption on the disk itself as part of protecting the data. The issues around that is, first, you need to wait for the development of those elements before you can use new disks. And the second is that protection is per disk, not per user. With the encryption and decryption elements with ConnectX-6, now we can do it within the network, so let's cover all of the disks that you have, for example. And since we do it on the NIC, we can do it per user and not per disk. So we can create protection between users. So this is one example of usage model, and there is many others. Here we see the illustration on the multi-host technology that enables one NIC to connect to up to 8 different hosts. Each host is connected separately. There is an embedded switch within the adapter to do all the switches among the virtual machines on every host and between the multiple hosts that connect to the adapter. And then the traffic goes all the way on 200 gigabit per second speed to the network. So that can reduce the 50% saving on the data center infrastructure, and for systems that do not require the highest speeds, that can change their economics. So we talked about ConnectX-6. Now we can move to talk about Quantum, the world's first 200 gigabit per second switch. Here we see the main highlights of the switch. We already mentioned the 200 gigabit per second per port and the capacity, which is almost 2x higher versus the competition. Quantum maintain the lowest latency out there in the fabric for switching elements of 90 nanosecond switch latency or port-to-port switch latency, which is 20% better than the proprietary competition out there. And increase the message rate on the switch to almost 400 million messages per second, which is 2x higher versus anything out there. On a scaling perspective, Quantum enables to build 128,000 nodes in a three-layer factory, 400 gigabit per second, which is almost 5x higher versus the competition. So that's the highest scalable switch out there. In my opinion, again, the more important part is the enabling the data-centric architecture. So Quantum brings the in-network computing element to enable data computation everywhere, enable doing data aggregation and data aggregation and data reduction algorithms wherever the data is. And of course, as the most flexible switch, it provides flexible topologies all the way from FAT3, Torus, Dragonfly, Mesh, Hypercube, and many other topologies. The radix of the switch that supports 80 ports of 100 gigabit per second or 40 ports of 200 gigabit per second makes Quantum the most efficient switch out there. So it requires 50% fewer switches and cables versus the competition for the same network throughput. So definitely deliver the lowest total cost of ownership and change the data center economics. We're putting here two examples of building two infrastructures. One of them is a small infrastructure of almost 400 nodes, and you can see that with Quantum, we requires 40% fewer switches and 50% fewer cables versus the competition. So this is one example for driving the lowest total cost of ownership. And we have another example of going to 1,500 nodes, and here that you see that with Quantum, we require a single switch, single modular switch. So it's 66% less real estate, 75% fewer cables, and 50% less power saving, or less power consumption when you go with InfiniBand. Again, HDR change the data center economics. And Quantum, as part of the in-network computing, have the SHAIP technology or enhance the SHAIP technology that enable the switch to manage and execute data algorithms on the data itself. It's a great fit for high performance and machine learning operations, and enables our users to achieve up to 10x performance improvement for HPC and machine learning communications. So that's, in my eyes, probably the most important element. The intelligence within the networks enable us to move faster to the data-centric architecture and to enable better performance, efficiency, and scalability for the next generation of applications. So, as we announce all of the elements for HDR 200 gigabit per second, we are going to offer next year the Quantum switch, ConnectX-6, and the LinkX cabling for both copper and silicon photonics to build the complete infrastructures for 200 gigabit per second. At Supercomputing Conference, we do invite everyone to visit the Mellanox booth. We'll have people or folks will be able to see the Quantum switch and the boxes, as well as ConnectX-6 adapters at the Mellanox booth. And we'll be very happy to demonstrate or showcase the capabilities of HDR to enhance the next generations of compute and storage platforms. Here we see different examples of how InfiniBand today deliver higher performance versus anything else. So from 20% all the way to almost 50% performance improvement on different kind of applications when people use InfiniBand versus a proprietary competitive product. So InfiniBand remains the best technology out there to drive the best performance from applications. And HDR InfiniBand will increase the gap even further, I think, to deliver a generation head advantage of our proprietary solutions. We did videotape multiple Mellanox users which express their criteria for their infrastructure and why they choose to use InfiniBand versus something else. And I think those elements are very known, and those reasons are very known. If it goes from the co-design approach that enables to build a data-centric architecture to a solution that gives them better performance on not just on application, but better performance on the CPU, for example. So when you use InfiniBand, you can maximize the efficiency from the CPU. You can even double the efficiency of the CPU when you use InfiniBand. So that enables you to maximize the system capability. If it's the backward or future compatibility, which is very important, you can connect storage to compute, and you know that you future-proof your data center, and other reasons. Um, People are more than welcome to visit the Mellanox HPC webpage on mellanox.com, and you can see the full videos there. Today, we're very happy to be part of the number one system in the world, and many other systems, leading compute and storage infrastructure worldwide. We're very happy to announce HDR and going to the next generation of network technology, doubling the speed, bringing more intelligent, more acceleration engines, and enable the data-centric architecture based data centers. We're very happy to be chosen to potentially connect the future number one systems in the world. And Mellanox will drive HDR to be part of future systems, and we expect to start putting the HDR-based systems throughout 2017.
Well, thanks, Gilad, for that preview. I guess you mentioned that this stuff will be in the booth, the Mellanox booth at SC16. Will these be operational devices that you're showing?
No, we're not gonna demonstrate. We're gonna do demos at this stage. We will showcase the devices. So we will showcase the quantum switch, both a device and a box, and we'll showcase the ConnectX-6 adapters. We do plan to do demonstrations in next year and to ship next year to platforms that will be built based on HDR in 2017.
Okay, so shipping in 2017. So this is coming in the near term, HDR from Mellanox. That's pretty exciting.
Yeah, definitely. The market needs it, and it's not just HPC. It's if you look on machine learning, it's definitely an area that requires or needs the same technologies in HPC. Look on storage, look on hyperscale, look on other places. Our users requested us to bring 200 gigabit per second even this year. So we see the need. There is a great need for that, and we're very excited to be able to announce this year, and we'll ship 200 end-to-end 200 gigabit per second to our customers next year.
Okay. Well, Gilad, I wanted to ask you a little bit about slide 10 and double click there because we've been talking about this in network computing, and this is the first time on slide 10 that I've seen this kind of broken down into these various components, right? And my question is, does this apply just to InfiniBand, this in-network computing, or does this work for the Ethernet side as well?
Well, in network computing, it's much beyond a specific transport.
Mm-hmm.
So it's not related it's not related to running InfiniBand or Ethernet. It basically enables to increase the data center performance by having more acceleration and intelligence within the adapter. So short answer, it is applicable to both InfiniBand and Ethernet.
Terrific. I guess because this is the first time I've heard any talk of 200 gigabit Ethernet. So that's very exciting as well for a lot of data centers out there. Do you see this as far as deploying that this quantum switch? Do you see this becoming kind of a hub for the big data centers out there? Do they typically use the highest end kinds of devices for internet centers like the Facebooks and other things out there?
Yeah, let's put it like that. The ConnectX-6 support both InfiniBand and Ethernet.
Yeah.
So it's bringing the technology for both. Quantum is InfiniBand switch, and it's bringing the 200 gigabit per second to the InfiniBand world. And the combination of Quantum and ConnectX-6 enable complete end-to-end. InfiniBand is definitely being used outside of HPC in many areas. If it's hyperscale, cloud, databases, and so forth. Mm-hmm. And there is the reason of in-network computing on one side. There's also the reason of economics. And yeah. InfiniBand is probably the best cost performance network out there. So yes, people will use Quantum for multiple infrastructures. We cannot put names in right now, as you probably.
Mm-hmm. A little early for that.
Yeah. But yes, there will be multiple usage models for Quantum.
Well, great. Well, hey, Gilad, this is exciting news, and I want to thank you once again for sharing this with us on our show today.
Yeah, I was very happy, and again, it's going to be an exciting conference for us, exciting news, and thank you very much, Rich, for helping us to provide this information to your readers and listeners.
Oh, it's my pleasure. All right, folks, that's it for the Rich Report. Stay tuned for more news and information on high performance computing.